Good morning everyone. So recall that in the last classes we have mainly discussed about the generating function in the case of the problem of selection with repetition without repetition. And we have also discussed how to find the generating function in case of the partition. So now I can say that the generating function for the problem of selection with repetition or without repetition is said to be ordinary generating function. It means we will address or we will try to find the generating function for the problem of arrangement, which would be known as exponential generating function. Why exponential I will discuss later. So to proceed further, let's consider the following problem. So we need to find the number of different words of 4 letters where letters are chosen from unlimited supply of A, B and C such that the word must contain at least 2A. Yes. So at least 2A means there are the following possibilities. There are either 2 A's, 3 A's, so 2 A's, 3 A's or 4 A's. So if there are 4 A's, so recall the problem of arrangement with limited repetitions. We used to consider n factorial by r1 factorial, r2 factorial and so on. So similarly it will become, if all 4 are there, so 0 factorial plus if 3 A's are there, then there could be 0B and 1C, or there could be 1B and 0C. If 2 A's are there, so 4 factorial, then 2 A's, so 2 factorial, and there could be 2 B's, 0C, or there could be 0B, 2C, or there could be 1B and 1C. Yes, even you can observe here is that the possible selection of 4 letters are A, B and so on. So total 6 brackets are there if we consider problem of the selection, because we are not considering the order. But when order comes into the picture, then this is how the solution looks like. Now if I talk of the generating function, then in case of the selection it would look like E1 plus E2 plus so on is equal to R. This is how we write down the generating function. Yes, in this particular case it is E1 plus E2 plus E3 is equal to 4, where E1 is greater than equal to 2 and E2, E3 are greater than equal to 0. And what I need the coefficient. If I using the ordinary generating function, if I find the coefficient of x raised to the power 4, it would for surely comes out to be 6, because each bracket is contributing 1. But in case of the arrangement, you can see that each bracket is not contributing 1. For example, C is contributing 4 factorial by 2 factorial, 0 factorial and 2 factorial. Yes, it means that instead of 1, the contribution is E1 plus E2 plus E3 factorial divided by E1 factorial, E2 factorial, E3 factorial, such that E1 plus E2 plus E3 is 4, E1 is greater than equal to 2 and E2, E3 is greater than equal to 0. Yes, so it means that so in terms of the generating function, the coefficient of x raised to the power r will count all formal products with associated coefficients. Yes, so this leads us to write down, how do we write down the required exponential generating function. So let's first define what is an exponential generating function. I will come back to this one, that how it is related to the definition which we are going to propose. So exponential generating function is denoted as a0 plus a1x plus a2x square by 2 factorial and so on, where AR denotes the number of the arrangement. It means in case of the ordinary generating function, we used to look for the coefficient of x raised to the power r. In case of exponential generating function, we would be looking for the coefficient of x raised to the power r by r factorial. Yes, and in ordinary generating function each terms are simply x raised to the power 1, x raised to the power 2 and x raised to the power 3. Now you divide it by x raised to the power 3 by 3 factorial, x raised to the power 4 by 4 factorial, and so on. Yes, it means that we are looking for the coefficient of x raised to the power r by r factorial. So if you recall the same problem, then what we say that if I write down the exponential generating function, then this exponential generating function should give me the required coefficients. Let's see how it is. So first thing, what would be the exponential generating function? So exponential generating function means at least 2 is, so x square by 2 factorial plus x cube by 3 factorial and so on. And for the rest, 1 plus x square by 2 factorial so on whole square. So this is my required generating function. Now I want to prove that the coefficient of x raised to the power 4 by 4 factorial should give me these 6 terms, or this should be the coefficient. If I put a plus in between, this should be the coefficient of x raised to the power 4 by 4 factorial. Now look here. So if you look here, then the coefficient of x raised to the power r will be the sum of all products. So if I am looking for x raised to the power r, so from this bracket I will get x raised to the power e1 by e1 factorial. Yes, from this bracket, the second bracket, I will get x raised to the power e2 by e2 factorial. From the third bracket I will get x raised to the power e3 by e3 factorial, provided e1 plus e2 plus e3 is 4, e1 is greater than equal to 2 and e2 e3 are greater than equal to 0. Yes, it means that this looks like x raised to the power e1 plus e2 plus e3 divided by e1 factorial, e2 factorial and e3 factorial. This is actually x raised to the power r. And what I am looking for, the coefficient of x raised to the power r by r factorial. So I multiply and divide x r factorial, and this becomes e1 factorial, e2 factorial, e3 factorial. So now you can see that the coefficient of x raised to the power r by r factorial is r factorial, where r is e1 plus e2 plus e3 divided by e1 factorial, e2 factorial, e3 factorial. So this is what we are looking for. So we just proved that for this problem we got the required answer using the concept of exponential generating function. Initially we wrote the answer using combinatorial techniques, and now we wrote in this way. Now let's do some exercises. So find exponential generating function for the number of arrangement of R objects chosen from 4 different types of the objects, where each object appearing at least twice and at most 5. So it means EI is at least 2 and at most 5. So 2, 3, 4, 5. Therefore we will get x square by 2 factorial, x cube by 3 factorial, x4 by 4 factorial, x5 by 5 factorial. And since there are 4 different types of the object, so 4 different boxes are there, therefore raised to the power 4. Write generating function for the number of R arrangement without repetition. So first recall the number of the arrangement without repetition, it is NPR. Now we have to show the same using generating function. Now what would be the generating function? It is without repetition. It means each EI is 0 or 1. Yes, it means that each bracket would be 1 plus x by 1 factorial, and there are n brackets, so this is the required generating function. Now in this generating function I am looking for the coefficient of x raised to the power r by r factorial. This need to be find out. Now the coefficient of x raised to the power r is NCR. It means I can write in this bracket there would be a term x raised to the power r n factorial n minus r factorial and r factorial. If I take r factorial with x raised to the power r, so this coefficient would be n factorial by n minus r factorial, which is pnr. Yes, so we have proved that the number of r arrangement without repetition of an object is npr using generating function. Find the generating function for the number of ways to place r distinct people into 3 different rooms with at least one person in each room. So again we have to write down the generating function, but recall that when we say r identical object, then it is a problem of selection, and when we say r distinct object, it becomes a problem of arrangement, and that's why we need exponential generating function. Writing down is quite easy, at least one person, so each ei is greater than equal to 1 and so on. In case of even number, it is 1 plus x square by 2 factorial and so on. Find number of arrangements of r objects chosen from unlimited supplies of n types of the object. Yes, now recall this problem and recall that we did a problem where we need to deploy 100 diplomats to 5 countries, and it was 5 raised to the power 100. So if you recall it, it is actually the arrangement of r objects, so n raised to the power r. But how it comes using generating function, that need to be seen. So now the generating function would be 1 plus x square by 2 factorial and raised to the power n, which is e raised to the power n, e raised to x and raised to the power n. Since this generating function, whenever we write down, it can always be expressed as an exponential function, therefore this generating function is known as exponential generating function. Now this is e raised to the power nx. It means if I write down the expansion of e raised to nx, it is something like this, where the rth term would be n raised to the power r x raised to the power r by r factorial. So clearly the coefficient of x raised to the power r by r factorial is n raised to the power r, and since it was unlimited repetition, that's why we choose each ei to be greater than equal to 0. Yes, find the number of sequence of length 8 that can be formed using this. Now again it is a problem of arrangement, but with limited repetition. So in case of the arrangement, there were 3 cases: no repetition, npr; limited repetition, it is n factorial by r1 factorial, r2 factorial and so on; and unlimited repetition, which is n raised to the power r. So this is limited because a can be 1 2 3, b can be 2 3 4 and c can be 0 2 4. Yes, so it means that I have to write down the generating function, which is x plus x square by 2 factorial plus x cube by 3 factorial, then x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial, and 1 plus x square by 2 factorial plus x raised to the power 4 by 4 factorial. Now I need to find the coefficient of x raised to the power 8 by 8 factorial. Yes, so I have to look for the different combinations. If I take this x, then x multiplied by this x cube and x raised to the power 4, so that gives you x raised to the power 8 by 2 by 3 factorial and 4 factorial. If I take this x square, I can again pick x square from here and x raised to the power 4 from here, so it would give me 2 factorial, then 2 factorial, 4 factorial. I can also pick x square from here, x raised to the power 4 from here, and x square from here. So again I will get 2 factorial, 2 factorial, 4 factorial. I can pick x cube and x square. So 3 factorial, 3 factorial, 2 factorial. Yes, and I need the coefficient of x raised to the power 8 by 8 factorial. So multiply and divide. These two terms are same, so I will get the coefficient of x raised to 8 by 8 factorial as 8 factorial by 3 factorial 4 factorial. I can add these two terms, so that gives me 8 factorial by 4 factorial 2 factorial, and the last one gives me 8 factorial by 3 factorial 3 factorial 2 factorial. Now you can also observe here is that if you have to find or if you have to solve this without generating function also, then this is not difficult. Yes, but we are going to see the problems which are not easy using combinatorial techniques, but using generating function they are very easy. So this is the first one. It says that find the number of r digit quaternary sequences with an even number of zeros and odd number of ones. So first write down the generating function. So even number of the zeros, which means 1 plus x square by 2 factorial and so on. Odd number of the ones, which is x plus x cube by 3 factorial and so on. And the last one, last two digits, there is no restriction. Yes. Now the first important observation is that this is equal to e raised to the power x plus e raised to the power minus x by 2. Please do remember this formula. You can verify by yourself. The second term is e raised to the power x minus e raised to the power minus x by 2, and this is simply e raised to the power x square. So my generating function would be e raised to the power x plus e raised to the power minus x by 2. Then this one, and then e raised to the power 2x. If you simplify it, then it becomes e raised to the power 4x minus 1 by 4. Now coefficient of x raised to the power r by r factorial. So 1 by 4 does not contribute anything. So e raised to the power 4x would contribute 4 raised to the power 4, and this 4 would also be there. So this would be 4 raised to the power r minus 1. Now if you try using the combinatorial techniques, then this is not an easy exercise. And there is one more issue with the combinatorial techniques is this, that many times there is a large chances of the mistakes, because you may consider some repetition of the solution, you may miss some cases. But in case of the generating function, there are very few chances. You can only do algebraic mistake, but combinatorially it works itself. Number of ways to distribute n objects to 5 different boxes such that the fifth box has even number of the object. So fifth has even number. So fifth contribute to e raised to the power x plus e raised to the power minus x by 2, and the other contribute e raised to the power 4x. So coefficient of x raised to the power n by n factorial is, from here it is 5 raised to the power n, and here 3 raised to the power n by 2. Next one says positive even number. So ei start from 1 only. So e raised to the power x by 2, and 1 should not be there. So the generating function would be x square by 2 factorial plus x raised to the power 4 by 4 factorial and so on. So I have to include minus 1 here, and e raised to the power 4x, which is e raised to the power 5x plus e raised to the power 3x by 2 minus e raised to the power 4. So coefficient of x raised to the power n by n factorial is 5 raised to the power n plus 3 raised to the power n by 2 minus 4 raised to the power n. Again you will see that if you use the combinatorial techniques, then it is more difficult to address. So last question, find the number of ways to place 25 people. Again, when we say 25, it means distinct objects are there in 3 rooms with at least one person in each room. Now at least one means that the generating function would be so on and cube, which is e raised to the power x minus 1 cube, which is e raised to the power 3x minus 3 e raised to the power 2x plus 3 e raised to the power x minus 1. And now I have to find the coefficient of x raised to the power 25 by 25 factorial. So the first term contribute 3 raised to the power 25 minus 3 times 2 raised to the power 25 plus 3 times 1 raised to the power 25. Yes. Now if we see combinatorially, then it is comparatively more difficult problem. Let's see how does it represent. So it says that at least one person in each room, it means none of the room is empty. So the total number of the possibilities to place 25 people into 3 rooms is 3 raised to the power 25. And now we subtract those possibilities where there should not be any empty room. Yes. So if there is an empty room, let's say 3 rooms are there and one of the room is empty, it means you distribute 25 people into 2 rooms. Yes. And which 2 rooms? These 2 rooms should be selected by 3C2. Yes. Other possibility is one of the room is empty. Yes. So you put all 25 people into one room. This can be done in only one way. All 25 in one room, 1 raised to the power 25. And how do you select this room? 3C1. But if you see the two answer does not matches. Combinatorially I don't have to see any repetition here, but in this case I have to see combinatorially what is wrong. So when I consider the case when one of the room is empty, then what will happen is that all 25 can go into this room also, and all 25 can go into this room. So these two cases have been actually repeated when I say that only one room is empty, because in this case if all 25 goes here, then also all 25 are going in one room and 2 rooms are empty. So this case is quite coming twice, therefore I have to add them twice, plus 3 and plus 3, and that gives the combinatorial reason. So you can see that combinatorially it is more complicated to understand and there are more chances for the mistakes, but algebraically it's comparatively very simple. Thank you very much for watching.